Hello friends, welcome back. In this playlist, we are going to handle the embedded Java interview questions. We will have about 50 questions that are connected to embedded systems plus Java. You are going to program embedded systems with Java as well, and embedded Java is on the rise. So we will have a detailed 50 question analysis in this session, which are very crucial for the interview. In this session, we will handle about 10 questions first, and then we will go to the rest of the questions in the sessions to follow. The agenda is very simple and clear. We will understand embedded programming aspects with Java to develop and to understand the best practices that one should follow for programming in Java for embedded systems. We'll go to the questions right away. What are the different segments of memory? Stack segment, heap segment, and code segment. Stack segment contains the local variables and the reference variables. A reference, as you know, is nothing but the address. Heap segment will contain all the created objects in runtime, the objects plus their object attributes. All the attributes will come in picture here. Code segment is where the actual compiled Java bytecodes will reside. So this is all about the code, that's it. So we have three segments: stack, heap, and code. Explain the memory management in Java. The programmer has got a lot of luxury when it comes to Java programming, unlike C or C++. In C or C++, the programmer has got the direct access to memory allocation, and in fact, the references can also be accessed, and that is what is leading to many memory leak errors. And the possibility and the room for memory leak is more when it comes to C or C++. But in Java, the developer does not have to worry anything about memory allocation, or he does not have to do it explicitly, and allocation and deallocation is all taken care of by garbage collector. The garbage collector has got the duty to handle the memory allocation so that the developer can be literally free and no worries are there with respect to memory management. What is a garbage collector? Give a brief note. Garbage collection is one of the very important features that Java gives you. Garbage collection is the process of looking into the heap memory, identifying which objects are in use and which are not in use, and whatever is identified as unused, that will be deleted. I repeat, I'll look into a box. There will be some objects which are used and which are unused. The unused objects are to be removed. That's it. This is taken care of by garbage collector. An in-use object or a referenced object means that some part of our code will maintain a pointer to that object, which means the object is being used even now. An unused object or an unreferenced object, see the term, unreferenced object is no longer referenced by any part of our program. So the memory used by the unreferenced object is an overhead for us, and that can be removed or deleted. The biggest advantage or the feature that we need to highlight for the garbage collection is that it removes the complete burden from the programmer for allocation and deallocation, so that the programmer can build the structure of the program in a better way towards solving problems that are more connected to it. Instead of wasting time on how to allocate memory, how to deallocate memory, the programmer can now stay free. What happens when an object is created? This is a very important question in interview particularly, so please listen to it carefully. The memory is allocated from heap to hold all the instant variables and implementation specific data of the object and its superclasses. I repeat, the memory is allocated from heap. The point is important here, it is allocated from heap, and it will hold all the instance variables and implementation specific data of object and its superclasses. If you do not know what a superclass is, it needs some more learning. I'll teach you that little later in my other sessions that I'm planning to do in the future. Now the implementation specific data will include the pointers to the class and all the class data, method data as well. The instant variables of the objects are initialized to their default values. This is the second step. The instant variables will get initialized to default values. Now comes to the term constructor. We know what a constructor is. It is used to initialize something. I have taught you this in my embedded C++, C++ sessions as well. What is constructor used for? It will be invoked the moment a particular object is created. Now the same is the case here. The constructor for the most derived class is invoked, which means the last created class will invoke the constructor, and first thing that the constructor does is to call the constructor for its superclass. Superclass is nothing but the parent class when it comes to C++. So I'll now invoke the constructor for the superclass. This process continues until the constructor for the topmost priority hierarchy class java.lang.Object is called, and that's the base class for all the objects in Java. Remember, first step is memory allocation, second step default values are connected to it, third step constructor is called, and the final step, before the body of the constructor is executed, all the instance variable initializers and initialization blocks are executed, and then the body of the constructor is executed. Thus a constructor for the base class completes first, and then the constructor for the most derived class completes last. This is the same procedure that we follow in C++. The constructor for the base class will be called first, and then the sequence continues, and the last one will be the last derived class. So this is what is happening when you get an object created. Okay, memory allocation for the object and reference. How are memory allocated for object and reference? When an object is created, memory for object is allocated in heap. I mentioned this in my previous question as well. When an object is created, the memory for that object gets allocated in the heap. Memory for the reference variable pointing to the created object will be allocated in stack. Remember, the memory for object is in heap. The memory for the reference variable is in stack. Now, when is the memory for static variables allocated? I need to allocate memory for static variables. During when? When is the memory allocation happens? It is allocated when the respective class gets loaded into the memory. That's all. It is allocated when the respective class gets loaded into the memory. Now the question is very important. What is a string pool? This is a very important question. It is a special storage area in heap memory. Remember, string pool is a constituent part of the heap memory. When a string is created using double quotes, normally when we create a string, we put a double quote. So when a string is created using a double quote, the JVM, the Java runtime environment, checks if the string is already available in the pool. I have created, for example, something called India. It will now check if India is already available in the pool. If yes, then the reference to the string will be returned to you. It is the return value. Now if it is already available, I'll get a reference return. If it is not available, I'll create a new string in the pool, and I'll then create a reference for it and I'll return it. This pool is based on the concept called as strings are immutable. Remember, the strings are immutable. I have got some string created. I want to create some string. I will check first if it is in the heap. If it is not in the heap, I'll create it and I'll give a reference to it. If it is already in the heap, I'll refer it again to you by returning the proper address file. That's it. Now let's take a simple question in the same area. String s1 equal to abc, string s2 equal to abc, string s3 equal to new string abc, new space string abc. Now how many objects are here is the question. Okay, first line, the JVM will check if ABC is there in the string pool. In the string pool, if it is not there, it has to be now newly included. So the reference has to be written. Now this new object is created. And now this reference is written. Now second line, I try to create it again. S2 equal to ABC. ABC is already available. So no new object will be created as of now. And the reference of the S1 ABC will be returned again. Now in the third line, when you use new, I mandatorily tell the system that I need to create it. I need to create a new object again. When I use the term called new here, new string ABC, it will be created again. So what is the answer? Here for these two lines it will be 1, and here for this line it is 1. So two objects are created. What is a class loader? The class loader is nothing but part of a JVM which is used to load the classes and the interface. Example of class loaders are the Bootstrap, the extension, and system. They are the class loaders that are used by JVM. What are the different class loaders used in Java? Bootstrap, it loads the JDK internal classes and Java packages. Extension loads the jar files from the Java extension directory. Usually a libext directory of the JRE is what is connected. Now the system loads the classes from system class path. So we have got three very important class loaders. One is Bootstrap, second one is extension, third one is system. That's what we have seen in the previous question as well. Differentiate static loading versus dynamic loading. Static loading is, as the term tells you, it is 100% static. We have seen this also in C and C++. So if you do not understand what is static and dynamic memory allocation with respect to C and C++, I request you to see my C and C++ videos. Static loading, classes are statically loaded with Java's new operator. We have got a new operator, and I have seen this sometime past also. So new operator will help you in loading the classes statically. Dynamic class loading is a technique where programmatically we will invoke the functions of a class loader during runtime. I stress it, during runtime if we can invoke, that is called dynamic class loading. Differentiate load class method versus class.forName method. Load class method just loads the class but it doesn't initialize the object. But class.forName does the initialization as well after loading it. That's the difference. Load class just loads. Class.forName, it also initializes it, and that's the point. java.lang.OutofMemoryError. What is this? Explain. This error is thrown when JVM does not have sufficient memory. When JVM cannot allocate memory for an object because it has got no more memory available, this is the error that will be thrown to you. Can finalize be overridden? There is a method called the finalize method. Can it be overridden? And this finalize method is invoked by JVM when an object can be garbage collected. What do you mean by a garbage collected? When there is no reference further available for that particular object, it can be removed. When the object has got no references, it can be removed. That's what the garbage collection is all about. So this method should not be overridden because garbage collection is taken care of by the system itself and it is pointless in touching this method. But again, I say that this should not be overridden. If you want, you can try that out as well. But this method is completely deprecated in Java 9 and eventually be removed for additional security. So remember it, this can be overridden, but it should not be overridden because this is 100% connected with garbage collection, and most importantly, it is taken care of very nicely, so let's not touch it. The learning shall evolve, and we'll have next set of 15 questions in the next session. Thank you for the support you are giving me. If you have any questions, suggestions, please go ahead and type it in the comment section. If you like the channel, please subscribe and refer it to your friends as well. Thank you.